full disclosure, this is my third time recording this video. Whew, very fun, very exciting. Hey, find the slope and y-intercept of each equation. Remember, slope is right in front of the x. We use the variable m for slope. So we'll find the slope of all four of these first. Number one, slope is 4. Number 2, we have 4/5. Number 3, in front of the x, we have the -1/3. And on number 4, we have 6. Now the y-intercept is the number dangling at the end. It's a constant. It's just a plus or minus almost always at the end. Sometimes they'll put it in front if they're being silly. But it's the number without the x. So on number 1, we have b equals -3. b is our y-intercept. Number 2, b is 7. Number 3, the b is -8. And number 4, oh dear, there's nothing back there, which means b equals 0. Now they're going to give us the m and b, and we need to put that into slope-intercept form. So it says the slope is 5, the y-intercept is -1. That would be y equals 5x. You could say plus -1, but let's just say -1. That's typically how you'll see it anyway. Here, our slope is 2/5, so y equals 2/5 x. And our y-intercept is 4, so plus 4. Last one, our slope is -1, so -1x. Our y-intercept is 0, so -1x plus 0. You can clean that up. -1x is just -x, and you don't write plus 0. You just leave it without the plus 0. All right, so slope is our rate of change. If we're graphing, it's our rise over run. And the y-intercept is kind of like a starting point. All right, so let's see what we got. A car dealership has 40 cars in stock. So they're starting already with 40 cars. Their starting amount is like our y-intercept. Okay. The auto manufacturer will deliver new cars to the dealership by car carrier. Each carrier holds 6 cars. So every time a new carrier comes in, we're getting 6 cars. So our rate of change is 6. It's changing by 6 every time these carriers show up. So that's going to be our slope. It's our constant change. We need to generate an equation. We're always going to use y and x for us. So like our slope, our rate of change is 6 because each or per, that means multiplication, right, holds 6. So let's say 6x plus our y-intercept, starting amount of cars, was 40 cars. Great. So we're going to figure out our axes here. So total number of cars, we're going to say is our y. And then the x is the number of carriers, right? Each one held 6, so 6 times the number of carriers. So we're going to put carriers over here. Now we can scale these however we'd like. Let's say let's go with, I like doing numbers that are divisible by 4, just because it's easy to scale it. So like if I said 20 carriers, it's easy to find half-ish. And we can say that's 10 carriers. And then half between 0 and 10 would be 5. And then over here we have, we're going by 5s, 15. Great. Number of cars. Now this break in here means we can start wherever we want. So we're going to start actually at 40. Instead of starting at 0, if there's no break, you have to start at 0. But then our graph wouldn't start for a really long time since our y-intercept is at +40. So that break kind of just removes that blank spot on the graph. All right, now let's kind of figure out, if we had 10 carriers, if we're putting in 10 for x, 6 times 10 is 60 plus 40 is 100. So we need to make sure right here at 10 it's going to be 100. At 20, 20 times 6 is 120 plus 40 is 160. So we need to make sure we include 160 in there. So maybe we'll go by like 40s. So here's 40, 80, 120, 160, and then we can say 200. All right. So our starting amount, our y-intercept is 40. We know that at 10 carriers, 6 times 10 is 60, plus 40 is 100. So we'll be right in the middle of 80 and 120. 20, we said 20 times 6 was 120, plus 40 is 160. Now, we're not going to have fractions of carriers show up, right? You're not going to have 6.8 carriers. So in theory, this shouldn't be a linear graph. It should be a discrete graph where there are just points rather than a line. But because I scaled this not by ones but by fives, I'm just going to go ahead and make it a continuous linear graph. And yeah, again, we're not going to have fractions of carriers show up. But these are nice because you could be like, oh, well, about how many cars would we have if we had 6 carriers? And you can kind of trace it up and then back. And that would give you a general, now if it was scaled perfectly, you could get an exact amount. But honestly, the easier way to do it, if they were like, how many cars for 6, is to just substitute that in and solve it, which would give you 36 plus 40, which means you'd have 76 cars if there were 6 carriers that delivered cars. Great, we got one done. Ready for another one? Let's talk tennis balls. A sporting goods store sells cans of tennis balls. There are 3 tennis balls in each can. Each means multiplication. So 3 in this case would be our slope. Now remember, the y-intercept is like, are we starting with any tennis balls already? So let's read the rest of them. The coach of the tennis team is buying supplies. Write a linear function that relates the number of cans to the number of tennis balls and graph that. We're not starting with any tennis balls, so our y-intercept is 0. That's why we don't have a break in the graph. We're starting right at 0. Now again, we can scale it however we want. Let's say, let's go with we'll go cans down here. So that's our x, right? The number of canisters. And then the y is going to be the total number of tennis balls. Tennis balls. So let's figure out kind of what we want as far as cans. I'd say for this one, let's just go by ones. So let's go 1, 2. Just try to keep your spacing consistent. Oh, that's not very consistent at the end there. Let me erase that one. Now let's kind of figure out, if we did get 10 cans and each can had 3 times 10 is 30. So I want to make sure that I include at least 30 up here. So 30, and then we can kind of divide this in 3s. We'll make this like 20, 10, and then we can just make a mark for halfway between those, and those will be like the 5s. 5, 10, 15, 20, 25, 30. All right, cool. So we're starting right at 0. If we buy 0 canisters, we have 0 tennis balls. And then our slope is 3, so we'd go up 3 over 1. That's about there. We're at 3 for 1 canister. 2 canisters will be at 6, so we go up 3 over 2. 6 plus 3 is 9, so go up to 9 and go over 1. 9 plus 3 is 12 over 1. 12 plus 3 is 15 over 1. So right now we're at 5 cans, 15 tennis balls. Plus 3 is 18. Plus 3 is 21. Plus 3 is 24-ish. And we're at 27 and 30. Now this one I'll leave as dots since we marked every single canister. Again, we're not going to have 1.7 canisters purchased. We're not going to be doing that. So we can, if you put a line through it, it's fine. It just makes more sense with this data to have just dots because we're only buying canisters. We're not buying fractions of canisters. We're not buying decimals of canisters of tennis balls. So that's it. We're good. Now we're given the graph, and we need to come up with some information. Students in a 9th grade class drew the following graph to represent how much money would be in the class fund after washing cars at a fundraiser. Cool. What does the slop, that's supposed to say slope, and y-intercept of the graph mean for the given situation? So remember, slope is the rate of change. So it's how much we go up versus how much we go over. So if we look here, let's pick points that are easy to find. So like this point and this point. If we check our rate of change, this is starting at 30 and it goes up to 40. So it went up $10 and it went over from 2 to 5. So it went over 3. So it increased $10 to 0. And the cars went over by 3. So what that means, that 10 over 3, is that we earn $10 for every 3 cars. Nice. Now the y-intercept, remember, is always like our starting amount. If you look, our starting amount is about $25. So our y-intercept is, we're starting with $25 in the class. Cool. B, if the graph had the same slope but a y-intercept of 15, what could you conclude about the fundraiser? Well, the y-intercept was our starting amount. So if we're starting at 15 instead of 25, that means we're starting with $15 in the fund. So maybe someone just gave a $15 donation to get the party started. Who knows? C, if the graph had a slope of 5, what could you conclude about the fundraiser? Remember, the slope is how much money we're making. So here it was 10 over 3, which means approximately $3.33 per car. If the slope was 5, that means we're getting $5 per car we wash. Nice. Cool, we got one more. Suppose you drew the following graph to represent how far you ride your bike at a steady rate. What is your rate? Remember, the rate of change, the slope, these are all interchangeable. So we find 2 little spots here where we can definitely see the points. So like 0 is usually easy, and then 1 is pretty easy too. So from 0 to over here, we're rising up 12, and that's miles, and we're running over 1, and that's hours. So our rate is 12 miles per 1 hour, or 12 miles per hour. If the graph had a slope of 10, which our slope was 12, what could you conclude about your bike ride? That means our rate, or speed, averages in miles per hour. Instead of originally it was 12. That's it. So we're just kind of analyzing graphs. Remember, your starting amount is your y-intercept. Your rate of change is your slope. Look for words like each or per, and you'll get it. Oh my gosh, you've got this.